Okay, so good evening. First of all, sorry for today's class, but as per my communication, as you have heard, I had, this morning a car accident. So, I'm okay, but it was unfeasible to come to class. I don't want to lose this class because we are already behind schedule. So, I will upload an online lecture, but I think we won't lose any effectiveness because it's very practical based. Especially, I will show you a lot of stuff during the class through Excel. So I hope this will be as effective as a presence lecture. Last time, as we speak about error measurement for demand forecasting, we stop here. I give you an exercise to be done and to try to be solved. And now let's see the solution. And some hints coming on this. Okay, as you can see, here was the starting point. You have the forecast for the product and the actual demand for the product. The trick here was to just set the different parameters that you need to evaluate, the different indicators to evaluate performance of forecasting. As you can see here, you should evaluate first of all the error. The error for each product for each month is the difference between the actual forecast and the actual demand. So if you do this for every product, then in every month for each product, and every month for every month per product, and for every product, then you have the value for everyone. Same then for absolute value of the error. So here you see it's the same. You make the absolute value of the error or the absolute value of this minus this, and so on. Here you calculate all the all the measure that you need to then evaluate the performance indicator. So error square, percentage error, absolute value of percentage error, the value the difference between with the naive forecasting, and so on. Then it's just a matter of calculating these indicators, averaging the value that you have here. So then I will upload the Excel file, but basically it's just a matter of applying formulas. And you can see that then for each indicator, you can evaluate which product is the best and which product is the worst in terms of forecasting. For example, the more bias in terms of unit is product C, because it's overestimating the demand a lot. Product E instead is the best. Then you see, for example, for standard deviation of the error, the worst is product C again, and the best is product F. For the accuracy, instead, product C is again the worst, and product E is the best, and so on. So you can make some evaluation of on which product is the best and which product is the worst. But then once I have detailed value for each product, which are the overall forecasting performance of a company. Let's see this with an example, and then step back to our example in order to have a practical evaluation of this. First of all, you have we can see for each product we should evaluate the measure for each item. In this case, we just consider product 1. You see that the first period of product 1, so forecast and sale, but this is just an example. We should then enlarge the measurement of also period 5, 6, 7, and 8, and here you have it. If you just consider the first 4 period, if we calculate the bias and the mean percentage error and the mean absolute deviation and the percentage of mean absolute deviation, we obtain we obtain this value just applying the formulas. Then, I mean, we have more product. You see that we have more product, each one with their average demand, and each one with a value of bias, with a value of percentage bias, with the value of mean absolute deviation, and with the value of percentage of mean absolute deviation. If I want to know how much the company is biased and accurate in making its estimation, I need to, calculate what we call the weighted percentage bias and the weighted percentage mean absolute deviation, which is simply the weighted average on the average demand of the value of the bias and the percentage bias and the percentage mean absolute deviation for each product. Why we consider the percentage? Because we cannot consider the bias in terms of unit, because we don't know if A, B, and C are homogeneous in terms of units. So maybe this can be unit, this can be kilogram, this can be liter, we don't know. So we cannot make it this, because otherwise it will be merging apples with pears. So if we consider the percentage, we know that the unit of measure is the same for the three products. And in order to understand which is the average value of the company for bias and accuracy, we just multiply each value of, for example, in this case, of the percentage bias for the average demand of the product, and we do this for all the product, and then we make the ratio on the sum of the average demand. If it is not clear, just stick with our example. Okay, you see here I have copy and paste the value of the indicators here and the value of the average demand for each product. For each product, I just make the average of the value of the demand across the year for each product. Here we have the table, you see, and what we are interested is in understanding the average percentage bias of the company and the average percentage accuracy in terms of mean absolute deviation of the company. So it means that simply, as you see from the formula, I need to calculate for each product I had to multiply the value of the percentage bias for the value of the average demand, and I do this for each product, and then I ratio with the sum of this. Let's make it again, in order to be sure. For each product, I make percentage bias for each product multiplied by the average demand plus percentage bias of each product multiplied by the average demand plus this one and this one plus this one and this one plus this one multiply this one plus this one multiply this one, and I have the numerator, and the numerator is the sum of the value of the average demand. And you see that if I convert in percentage, we have the same value. So I have a demand which is overestimated on average 4%, and same for the accuracy. Again, I should do the value of the mean absolute deviation percentage of each product multiplied by the average demand, and I do this for all the products, and I make the sum, and then I make the ratio by summing all the value of average demand, and I obtain that on average the company is inaccurate on the forecast of 12%. Just a comment on the fact that when we talk about accuracy, bias, and so on, it's linked to the fact that forecasts are by definition not exact, and so when you give the forecast, you just don't give a number, but you give what we call confidence interval. So it's useful to provide the value that comes out from the model, so this one, but then a range under which this value can be vary and can be fall within. And in particular, if you calculate the indicators that I showed you before, we already comment that the root mean square error, which is the formula, so it's the difference between the forecast and the actual demand, square the average. So I sum and then I make the average, and if I then make the root square, I obtain it's the standard deviation. So as you see in statistics, in reality here you are saying that your forecast is, if you hypothesize the demand distributed as a normal curve, is made by the value you are given plus minus z times the deviation standard, where z corresponds of the probability on which you want that this value falls within your confidence interval. Of course, the higher the probability, the higher will be z, but the higher will be also the spread of values that you will given as possible for your actual number to match the forecast. Of course, when you build the model, you want to be as much as accurate as possible. So in your objective function, you will want to minimize the KPI measuring the bias and the QPI measuring the accuracy. So you want to have no bias and no accuracy, but this means also build a complex model. So if you want to increase your forecast accuracy and so decreasing your error cost, so the possibility to give a number which is different from the reality, you will also incur in higher cost of forecasting. So it will be more complex designing the model. Otherwise, if you rely on a simpler model, you will have less cost of forecasting, but of course higher error cost. It's up to you, according to company, identify the optimal value. So that value that gives you a fair level in terms of cost of forecasting and fair level in terms of error cost. For example, there are different factors that you need to consider, like the status of the market, so the variability, so how much is good to invest in a model that can be varied through time, or how much is important to be very accurate. So how much is the cost of making an error in forecasting? How much how higher is your flexibility in terms of if my forecast is wrong, how I'm able to react to this forecast and follow the actual demand without incurring in higher problem and so on. So you should consider a lot of variable in understanding which is the optimal value of forecast accuracy and cost of forecasting. Here you see an example. This is a practical example taken by a company in the fresh food industry that has tried to realize to model which was the curve of the stock out, which was the main consequences of the forecasted error in function of forecasting error. You see that here that before, let's say, 750 units, the cost of stock out was minimum. So if I were able to build the model giving me a forecast accuracy which falls within an error on 50 units, cost of stock out was minimal, while instead after 1000 the cost of forecasting was very high, because after 1000 the company was incurring in higher stock out, and stock out means not being able to sell to the final customer, and with also impact of images on brand and so on. So in this case the company chose to build a model which was as much as complex in order to be able to give at least a maximum error of 50 units from the actual demand, because this value was acceptable. After this, I mean, there were higher costs of stock out, and so we won't like our model we would like the probability for our model to be wrong more than 750 units in order to avoid this type of cost. Okay, if it is clear, we can now step on and say, okay, now we know how we can forecast and how we can measure forecast performance. Now we can focus more on, on demand characteristics and try to understand which is the how, first of all, is composed the demand, and which are the main techniques to manage demand in a company. First of all, the first things you have to do once you have some demand data is doing a demand analysis. So you just don't have to go through data and start building model and implementing algorithm and so on. But you first need to understand, to which type of events, of factor you are dealing with. And you can do that using demand analysis technique. Which are the main demand analysis technique? First of all, graphical representation. Graphical representation means, first of all, just question how to map and how to visualize most of the data. Like, for example, if it is a time series, simply mapping the time, and in correspondence of each time, the value of your demand or the variable you are analyzing. A second thing could be, I don't have a time series, I have two variables which can be related to the demand. For example, the revenues generated and the employees which I have been employed to serve a market. Make a scatter plot in order to, plot how much, to which level of revenue correspond which level of number of employee used to reach this type of revenue. So this means this helps you to understand if there is a relation between some variables that can be relevant to understand the nature of the demand. Then you have, apart from visual representation, you can give descriptive statistics. So, numerical representation of the demand. Descriptive statistics can be univariate or bivariate. Let's start with univariate. Univariate, I don't want to go through this, but univariate is all that is related to statistics, what you already see in statistics. So, in order to characterize, for example, the demand, you are interested in calculating the mean of the demand, so which is the average value, which is the median value, so which is the central observation characterizing your demand, or which is the mode, so the most frequent observation, or according to the data that you have, the highest probability of the value to be which is the value with the higher probability your demand will be adhered to. Then this is for evaluating the average or the central tendency. Then you have, how much our values have dispersed, and you can calculate through this range, so the difference between the max and the minimum value, the variance, which is the difference for each observation from the average square, and then sum up and divided by n or n minus 1, the standard deviation, which is the square root of this value, and the coefficient of variation, so the ratio between the standard deviation and the average, which gives you an understanding of how much the value are dispersed around the mean. Of course, the higher the dispersion. Then you have also bivariate statistics. So it means that you want to understand if not only which are the numerical value of characterizing your data set, but you're also interested in understanding if there are correlation between variable, or you see x and y are different variable you want to analyze, or it can be different data set, sub-data set of the same variable, like for example, one year of demand with the other year of demand. So you want to understand if a correlation exists between two variables or two subsets of the same variable. I don't want to deep dive in this formula because, I mean, then it's all automated. You don't need to calculate anything, but just to give you the idea. For example, if you have a variable which is A and a variable which is B, you see that, I mean, the trend is almost the same. So it means that when you evaluate the correlation coefficient, which is named R, will be, I mean, similar to 1. When the coefficient is similar to 1, it means that there is high correlation, and so the two variables are very similar. Instead, if you consider this example, you see that, I mean, the trend and also the value are quite different. So it means that if you calculate the coefficient of correlation, I mean, their value is likely to be near 0. This is an example. You see that here is two types of demand within the same period. So from January 96 to October 2002 for the same company in two different regions, Northwest and Northeast. As you can see, I mean, the trend and also the value are very similar. If you calculate the correlation between this series and the blue series and the red series, I mean, the coefficient of variation would be very near to 1, meaning that the two types of demand are really correlated. Then there is also another type of correlation, which is named autocorrelation. The autocorrelation measures the correlation between the observation in a particular period and successive observation in following period. I mean, for example, if I put, you see that this is RK and then this is the formula. If I measure R1, I'm interested in understand if the observation on period 1 is correlated on observation in period 2, which is correlated in observation in period 3, and so on. So measure the correlation between successive observations. R2 instead measure the correlation between observations separated by two periods, so 1 to 3, 2 to 4, 3 to 5, 4 to 6, 5 to 7, and so on. RK measures the correlation between observations separated by key periods. Let's show it from a graphical perspective. In this case, I mean, you see that you have the same time series, okay, same time series, with no lag. I mean, you see that here you have the same values in each period. So the lag is 0. There is no lag. Instead, the correlation is 1 because it is exactly the same demand. So the correlation between this one and this one is exactly the same. If I move, you see that. If I move, let's say, the time series of one period, so I lose the last one. You see, I lose the last one, observation. And the first one, I mean, if I try to correlate the observation in the same period with the other one, I can understand if there is autocorrelation. So if the demand is actual correlated to itself. In this case, with lag 1, 2 equals to 1, which means, I recall you, measure the correlation between successive observation. You see here, successive observation. If you move 1, you are evaluating if observation number 2 is correlated to observation number 1. If observation number 3 is correlated to observation number 2. If observation number 4 is correlated to observation number 3, and so on. So with lag equals to 1, I found, for example, that the correlation is not, so different from 1 is 0.82. So it means there can be a correlation between 1 and observation and its successive value. Let's try with 2. You see that I lose the last 2 observation in our demand, and I I sweep this time series of 2 periods. I'm evaluating is 3 if 3 is correlated to 1, is 4 is correlated to 2, is 5 is correlated to 3, and so on. And I found that the correlation, has been smoothed, because with leg equal to 2, we have correlation coefficient 0.72. Okay, let's consider this example that we will carry on this example during all the following explanation. So these are real data. These are real data. I took a company supplier, so supplier number 102, and the value for 50 months of what? Of the spending. So how much the company is spending each month with this supplier. You see, this is the time series, and of course we have, 98 is not 98, is 98 multiplied by 1000. So these are what we call kilo dollar, but just for sake of representation. Let's try to give some descriptive. As you can see here, you see that, for example, visual representation of data. So you just highlight this, okay, and you make insert graph, and you just display each period and the value of the spending. Okay, so this is a visual representation, and you see which is the trend of the spending all over this month. Then you can calculate the different variables that we have seen. You see that mean. Mean means that you simply have to, sorry, this is in Italian, but it's the same. You just have to type the command mean, okay, and you select all of these, then you click OK, and you have the mean. So, OK, and you have the mean. You want to calculate the median, just insert median as a command in the same interval, and you have the value of the median. The mode is OK. The mode is the same. So, type mode, and then select the interval, and you have the value of the mode. You want to calculate the range. The range is simply the difference between the maximum value of this interval minus the minimum value of this interval, and so on. Variance, again, you select here and you calculate the variance, the simple variance of this interval, as well as the standard deviation of this interval. So it's very simple. Then coefficient of variation is simply the ratio between the standard deviation and the mean. Let's now try to understand some correlation. Here, what type of correlation you see? For example, here I told you that these are years. Okay, so 1 to 12 is 1 year, 13 to 24 is a second year, and so on. For example, I want to analyze which is the correlation between the time series of the first year and the time series of the second year. You just have to type the command correlation, you open parentheses, and you select as the first matrix, as the first series, the first 12 months, at the second series, the second 12 months, you click OK, and you see that the correlation between the first year and the second year is 0.5, so marginal. Of course, please evaluate that the correlation can be also negative. Correlation, it means that positive correlation means that one series increase, the others increase. If the correlation is negative, of course it means the contrary. One series increase, the other series decrease. But this is valid, of course, if the value is near -1. So if it is near 0, it means there is no correlation, which is the case of correlation between the first year and the third year. You see that I just select correlation between the first year and the third year, and I see that the value is -0.0061, so it means that there is no correlation. And so on. You can do it for 1 and 4th year, so you evaluate the correlation for first year to every year, and for 2 to 3, 2 to 4, and 3 to 4 in order to cover all the possible combination. Last one, let's evaluate the autocorrelation. This is very easy. As you can see, this is the actual demand. okay? This is the actual demand. Lag equals to 0. It means that you want to evaluate if this series is exactly correlated with this series. I mean, you copy and paste here, okay? And here you just make the correlation between the first column with the second column, okay? If you want to understand the correlation of one leg, so if the second observation you see here is correlated with the first observation, if the third observation is correlated to the second, you just have to copy this, see that, copy, and paste, I mean, one step behind. Here, you see that? And then you correlate this series, okay, with this series, being careful to, I mean, to take, you see, only the first 50, in this case, value. So, I mean, you are losing, once that you are doing this job, you are losing more and more observation. You see that if you put here like equals to, correlation is evaluated like this. Okay, so you are losing more and more observation. We are put out of our analysis. Here, I mean, I just make the example until I think the second year, yeah, 24, and you see that, I mean, the correlation values can be neglected, are not relevant. But this is, I mean, very easy. You copy and paste and you evaluate the correlation. And here you can see if, I mean, there is some trend in terms of correlation between observation that can be linked to other time period of the same time series. I will upload an exercise, and I mean, I will upload also the example that we are seeing in this class, but I will upload an exercise and you can try to do that. So you will have four different time series, and I will put comments on one of these on what you can try to do with every one of these, and you can see how to go through the stuff that we see. That we have seen until now. Okay, now it's time to go. I mean, now we know how to measure the error. We know how to map and to visualize main statistics about the demand. Now, the first things we have to do before deep diving into the forecast model are, I mean, when you have a time series of demand, for example, which are the components of this time series? And in particular, we can see that when we have, I mean, a time series, a demand time series, so over some period of time, I mean, in our demand, we can identify two main components. One is called trend and cycle, so the fact that during years, I mean, the demand shows some trend, which can be increasing, decreasing, increasing, decreasing, decreasing, increasing, increasing. I mean, it depends, but I mean, during time, the demand has a pattern, a trend, and then it has also a seasonality. I mean, there are cycles in the history, in the market, and so on. It can be that, I mean, monthly, seasonally, weekly, I don't know, per semester, the demand during time, I mean, experience the same pattern during time. So periodical fluctuation of constant length. Okay. So here, generally speaking, is how we can, I mean, explain the value of the demand. Okay, the demand, which is named X in a certain period t, is function of, I mean, a certain seasonal component, a certain trend component, and as we are dealing with exogenous variable, an error component. Okay, which are the most diffuse relationship between this component? We have what we call the additive model, which is that the demand is simply the sum of these three components. So there is a part which is related to the seasonality, the part which is related to the trend, and the part which is related to the error. Or multiplicative. So the demand is given by multiplying the seasonal part to the trend part to the error part. Okay, it's up to you according to the context if it makes more sense the additive or the multiplicative model. I mean, by experience, I told you that companies prefer to use the additive model, which is, linear, which is more intuitive and so on. But please don't forget that also the multiplicative option exists. Okay. So first of all, which is when you know that the time series can be decomposed with, the additive model or the multiplicative model, which is, the procedure that you need to do in order to estimate this component. First of all, estimate the trend by the means of moving average, and we will see in a minute how to do estimation through the moving average. Then evaluate the residual component made by the seasonality and the error by subtracting the actual value of the demand to the trend. And based on this value, estimate the seasonal component using the average value of this in the different period. We will see that through an example. And then, of course, when you have estimate S in the period, you can then evaluate the error component by subtracting from the actual demand, the trend, and the seasonality. Same for the multiplicative model. Instead of subtracting will be ratio, but it's the same. The process is the same. First of all, let's try to understand how to evaluate the trend. The trend can be evaluated through what we call the moving average. The moving average is the basic tool to smooth a time series because it smooths the random variability. Moving average, named also K-moving average, wants to calculate the average of key value of a series by consider, only a select part of the data available. Which number? A key number of this value. So an order key moving average, key MA, is calculated by considering the last key values of a time series. Now we'll go to an example, but let's say that I can just say that in a certain period of time, I want, a 3 moving average, which means averaging the 3 value before the actual value I'm considering, or I can say that I want to calculate a center moving average. In the center moving average, we calculate a moving average centered in a specific time frame. So if I want a 3 moving average for each period, the average will be given by the value of the observation in the actual period, the value of the observation in the period before, and the value in the observation in the period after. Okay, so 3 center moving average. You see that 3, it is center here. It is centered here, and we use as the value to be average the one before, the one after, and the one in the middle. Okay, so it is essentially if it is 3 is and we are in the t time, we use t minus 1, t plus 1, and ratio 3. Okay, this is value if the value or the key value of the series of the moving average is odd. If it is even, it is a problem because you want, for example, to calculate a moving average of 4 period, okay, a 4 center moving average, and in reality the center is, if the period are 4, the center is here, okay? So, this is a problem because when it is 3, you center 3 period, you center the moving average here, you take the observation before, the observation after, and I mean, you average these 3 values. In this case, you don't have the value in the middle. So a moving average of an even order means to be managed in this way. So we just first make the hypothesis that, I mean, as I'm here, but I don't have this time of continuous observation. I will first be positioned here, and I make the average of the value, making, I mean, the balance, the balance. So 2 value before the 3 period if the moving average is 4, and 1 value after, and I make the first moving the first moving average. Then I calculate a moving average which is the balanced in the lower bound. So I add the 5 value and I consider this range. So this is centered, I mean, this is centered, I mean, with 2 after and 2 before. And then I have a first moving average resulting from the average of from 1 to 4 value, and a center moving average which is the result of 2 to 5. The 4 moving average is the average of these 2 values. I mean, now we will see it with an example, but I mean, essentially is the fact that when you have an even key order, you make for every period, you calculate for every period 2 moving average, and then you average the value to have the correct, the approximate value of the center moving average. And that was written here. The value is the average of 2 successive moving average. For example, if k is 4, you make 2 times a 4 moving average, one considering 2 values before and just 1 value after, and one considering 2 value after and 1 value before. I don't know if it is clear, but let's go through an example, and I'm totally sure that this will be clear. Okay, let's consider our spending, the same value, the spending, so supplier and spending, okay? Let's make the hypothesis that we want to, calculate a simple moving average of 7 periods. It means that for every period, okay, we want a new value that is the average of the 7 period before. Of course, I need to start from 7 because if I would be positioned here, I don't have 7 observations to be average. So I just position here in 7, and in 7, the moving average value of 7 period we will give in by the average of, the previous 7 period. Okay? I just click OK. If I just, put down here, you see that? I scroll down and obtain that in the second, for the period A, the moving average will be the value of the previous 7 moving average value. You see that? Again, the 9 period, the moving average will be the average of the previous 7 observation, and so on. This is a simple moving average, okay? Let's imagine that I want a center moving average of 7 period. Okay, center moving average means that for every period I want to calculate an average which is centered. Okay, centered on a period of 7. If the period is 7, it means that it is centered in 4. You see that if I am positioned in 4, I have 3 observations before and 3 observations after, and I can calculate the moving average as this one. You see that it is centered here, and I take 3 before and 3 after. Okay, and then I scroll down. Sorry, this is not. Okay, here. You see that in the second period, the moving average, which is centered here, will consider the 3 observations before and the 3 observations after. And so is for the other one. Of course, I need to stop once I don't have any more 3 observation after. So here, you see that? Here, if I'm positioned here, No, sorry. It was true before. Okay. If I position here, I just get 3 information after, 3 information before. If I go here, you see that you have no more observation, because here you don't have any more 51. So I mean, this is the last step you want to consider. This is very simple. If we consider the odd number, let's go with the even. Moving average of 7 period. Okay, moving average of 7 period means that, I mean, for every period you want the average of the 6 previous observations. So if I have on period 6, I want the average of each of the previous six observation. And again, you scroll down and you obtain that for period 7, from 2 to 7, from period 8, from 3 to 8. Okay, this is easy. This is like the moving average, the simple moving average on 7 period. Now let's go with the center, because if I want the moving average on 7 period to be centered, okay, it means that for, I mean, every period I need to have an equal numbers of observation before and after, I mean, and the total needs to be 6. You see that is not fitting. If I'm positions on 3, okay, I want 6 period. It means taking 2 before, 3. You see that? It's 3 and 2 after. Okay, so it's not center, because in reality the center will be between 3 and 4. So what I should include here? I will include a moving average, consider from 1 to 6, okay, plus the moving average from 2 to 7. If I average these two values, I obtain a proxy of the center moving average of 6 period, okay? That's why I was saying that it's like you make 2 moving average of a same period, considering different type of observation. One, you see that it has 2 values before and just 1 value after, and why here you have 1 value before and 3 value after. Okay, if you scroll down, you obtain, you see here, a center moving average of 6 period will consider 2, 3, 4, 5, 6, and 7, and 3, 4, 5, 6, 7, and 8. You average these two values and you obtain the actual value of the moving average. But I mean, this is more easy to be done in practice than in reality. Once you for example, let's imagine that instead of a center moving average of 6 periods, we want a center moving average of 4 periods. Okay? 4 period means that 4 period means that I mean, I need to center the moving average I mean on 4 observations. So it means that for example, on the first 4 observation the center will be here, so would be in the middle. So this means that if I am positioned here, I should first average. I have a balance which has 1 observation after and 2 observation before. I should make the average between the first 4, and I'm making not a moving average of 4 periods centered, because it is, I mean, I have 1 after and 2 before, so it's not really centered. So I need also to consider the fact that I can center considering just 1 observation before, and if I position in 3, 2 observation after. So I first make a moving average of 4 period considering the first the first 4 observation, and then I sum up a moving average, a simple moving average, considering the 4 observation of from 2 to 5. Okay. If I average this value by 2, so if I make the average by 2, you see that I obtain the average between a moving average of 4 periods centered on the first 4 observation and the moving average center of the second 4 observation. By average, I mean I obtain here, if I position in 3, something which is proxy of the moving average, really center, because in reality you see here in 3, but it should be between 2 and 3, so in 2.5, which is the center of of a moving average of 4 period. If scroll down, if I scroll down like this, you see that, for example, here, for the period 4, the moving average centered on 4 periods, consider a moving average which is considered the observation between 2 and 5, and the moving average I consider the observation between 3 and 6. If I make the average between these two moving average, I obtain a proxy of the moving average centered on period 4 on 4 period, and so on.